Namaskar my dear friends. Welcome to the lecture series of Computer Aided Manufacturing. In our previous videos we will learn about the introduction of Computer Aided Manufacturing and Computer Integrated Manufacturing and difference between the Computer Aided Manufacturing, Computer Aided Design and Computer Integrated Manufacturing in Unit 1 as per the syllabus of Gujarat Technological University. Now, in this lecture, we are going to start our Unit 2, that is the NC CNC machine tools, in part 1. Now, let us contents of these lectures: introduction to NC machines, principle of NC machine, evolution of NC controller, advantages and disadvantages of NC machines, and types of the CNC machine. Now, let us start with the introduction. So, before introduce the NC machine, let us go to the history of this machine. So, after the Second World War, there was a big spurt in the design and development of aerospace products like satellite, launch vehicle, civil and military aircraft, etc. So the hydraulic coping and electrical program control machine used at that time could not meet the manufacturing challenges posed by the complex aerospace designs. So the manufacturing engineers were therefore looking for a better way of automating the machining operations. So numerical control, that is known as the NC, was developed in early 50s to meet the critical requirement of aerospace industry. Many components used in aircraft and space vehicles are machined from solid raw materials and often involving the removal of the considerable stock and requiring several hundred positioning movement of the machine tool slides. Manual operation under these circumstances is not only tedious but also less efficient and unproductive. So often the part after several hours of machining is liable to be rejected due to the machining errors. Digital technology developed for communication purposes became very handy for designers of control of machine tool. So since the information required to actuate and control slides was coded numerically, so this technology came to be known as numerical control. So early this numerically controlled machine were fully hardwired machine, as the entire control logic was implemented in hardware. So this posed the several difficulties in the operation of NC machine, apart from the serious limitations on reliability of operation. So the designers of NC machines achieved a major breakthrough during mid-60s when they could integrate NC machine tool with a mini computer. So the technology was then renamed as a computer numerical control. So the integration of computers with NC machine tool resulted the numbers of advantages like the increase in memory for part program processing, increase in capacity for storing large part programs, easy editing of part programs on the control consoles, realization of control logic through software. So in short, we can say the numerical control is the technique of giving instruction to a machine in the form of code, which consists of numbers, letters of the alphabets, so punctuation marks and certain other symbols. Controlling a machine tool by means of a prepared program is known as a numerical control, and a definition given by the Electronics Industry Association, that is EIA, is a system in which actions are controlled by the direct insertion of a numerical data at some point. So the system must automatically interpret at least some portion of this data It means we are inserting some inputs in terms of some data, okay, and that may be a binary code, okay, and the machine will interpret that data, and accordingly it will produce the any product. Now, principle of operation of numerical control machine. Now you can see here, this is the principle of the numerical control machine. Okay. Now here you can see this is the machine control unit, from where the machine will be controlled. Okay, so the CNC machine, it differ from the conventional manual machine in several respects, and the principle of this operation of numerical control machine can be explained with this figure. Okay, so the figure shows the vertical milling machine, okay, for carrying out an operation like end milling. The spindle heads to be positioned in Z axis. Here you can see this is the Z axis, okay, where the spindle is to be positioned, and the table in X and Y coordinate axis. The feed movement is to be realized by the individual or the simultaneous movement of X and Y axis. Okay, so here you can see X axis and Y axis. Thus, this machine requires 3 slide movements, which are usually referred as axis feed drives. Okay, special features of a CNC machine is that the separate motor is called the servo motor, which individually drives each axis. So AC servo motors are the preferred choice for this purpose. Okay, and DC servo motors were widely used earlier. The slides are driven by the servo motors through recirculating ball screw and nut assemblies. So the use of this recirculating ball screw, it reduces the friction, backlash and wear. The low friction reduces the torque required at the motor and the lost motion through torsional deflection of screw. The use of ball screw also improve the dynamic response of the system. In some modern design, particularly in the case of high-speed machines, the linear motors are used in the place of servo motor ball screw combination. So in order to carry out the operations on the workpiece, the coordinate information, that is X and Y coordinates of the starting point and the ending point, has to be coded in the NC program. So similarly, the information regarding the direction of rotation and the speed of the spindle, use of coolant and the feed rate is also coded suitably. So the NC controllers, it decodes the positioning information coded in the NC program, and the slide is moved to the program position at the required feed rate. Each slide is fitted with feedback transducer. Okay, each the slide is fitted with the feedback transducer, so which continuously monitor the slide position and compare with the program position as well as the feed rate. Okay, so you can see here this is the transducer, okay, which gives the feedback. The feedback transducer is mounted either on the slides or on the servo motors and measures the displacement or position of the slides. Okay, so this is the basic principle of operation of numerical control. Now let us say one example. Let us assume that a hole is to be drilled, okay, at the location of X is equal to 100 and Y is equal to 150. Okay, so the corresponding block of the program is read by the control system, and the necessary input are sent to the X and Y axis servo motors. So these motors drive the respective slides to the commanded position. Okay. So when the distance information from the feedback device is equals the program value, the slide movement stops. So the input is then given to the Z-axis servo motor to perform the operation. Okay, so the system switches on the motor driving the spindle carrying the drill and command the Z-axis servo motor to move at the program feed rate into the workpiece till the program depth is reached. Okay, so the Z-axis feedback transducer ensures the correct depth and feed rate. So the drill is then withdrawn to the desired height and the machine starts the positioning movement to the next location of the drill. Okay, so this procedure does ensure the production of accurate workpiece. Okay, and the feedback transducer use it may be analog, or we can say synchro resolver, or digital, that is known as the encoder. So another classification of feedback transducer is based on their nature, measurement, absolute or incremental, and they are also classified as linear or rotary depending upon their construction. So we will see later on. Okay, now here the control of an axis in an NC machine tool. So the control of an axis in an NC machine, okay, it is closed loop positioning system, and the MCU, that is the machine control unit, it generates a pulse signal until the signal returned from the feedback transducer agrees with the original number of pulse required to execute the movement, and the comparator, which compares the count of feedback pulse with the original number and error signals in the output until the table reaches the desired position. And feedback transducer are linear or rotary encoders used to obtain the correct position or velocity feedback. Now here you can see the diagram or flow diagram of the NC machine. Okay, so you can see here the manufacturing operators. So it gives the numerical data, and this data in terms of number, letter and symbol. Okay, so that data is fed into the numerical controller. Here you can see. Okay, so this controller gives the command to the through the drive control through the machine. Okay, so here you can see the drive control unit is there. Okay, and this drive control unit gives the command to the machine unit, and this machine unit, it interprets the data, okay, given by this numerical controller, and accordingly it will process. Okay, then finally the process part will be introduced here. Now evolution of controllers. Okay, so the hardware technology in NC controls has changed dramatically over the years. Okay, at least 7 generation of controller hardware can be identified, and that the vacuum tubes in 1952, electromechanical relays in 1955, discrete semiconductors in 1960, integrated circuits in 1965, direct numerical control in 1968, computer numerical control in 1970, and microprocessor and microcomputers in 1975. Okay, the initial NC prototype machine built in the MIT, that is Massachusetts Institute of Technology, servo mechanism laboratories, use vacuum tube for the controller hardware. Okay, and these components were so large that the control unit consumed the more space than the machine tool. But that was the state of the technology in controls at that time. So by the time the first NC machines were sold to commercial market several years later, so electromechanical relays were substituted for the vacuum tube. The problem with this relay based control was their large size and poor reliability. So even the relatively simple point-to-point logic required several large cabinets filled with the relays. So the relays were susceptible to wear, and controls requiring a large number of these components were inherently unreliable. So the use of transistor based on the discrete semiconductor technology formed the next generation of NC controllers. So the use of transistor helped to reduce the number of electromechanical relays required. Accordingly, this increased the reliability because the use of transistors it avoids the wear problem. So it also contributed to downsizing of the controller cabinet, and it allows the system designer to build more complex circuitry into the NC controller. So features such as circular interpolation, it became practical with these controls. And size and reliability. Size and reliability, it still remained as problem with NC controls which use discrete semiconductors. Also, the electronics were sensitive to heat, and fan or air conditioner were required in the cabinets to operate under factory condition. So around 1965, the integrated circuit were introduced for use in NC controls, and this type of electronic hardware brought significant improvements in size and reliability. So the number of separate components it could be reduced by 90%. So there were corresponding saving in cost to the user. The trend towards LSI, that is the large scale integrated circuits, has allowed more control feature to be packaged into the smaller control cabinet. So among these features are circular and hyperbolic interpolation routines, inch to metric conversion, and vector feed rate computations. Then the next development in NC control marked the introduction of digital computers in NC controllers technology. So this constituted a fundamental change in NC evolution. So all of the previous controls were made up of hardware components, and the functions that were performed by this control system could not be easily changed. So due to the fixed nature of hardware design, digital computers are based on the different approach. So in this new approach, the control functions were programmed into computer memory and could be changed by altering the program. Okay, so by this way, the different evolutions of the controllers were made. Now, computer numerical control, that is the CNC. So CNC controls are soft-wired NC system, as control functions are controlled by software programs. So alternatively, the computer numerical control is the numerical control system in which dedicated stored program microprocessors are built into the control to perform the basic and advanced NC functions. The control signals in CNC systems are in the form of binary words, where each word contains the fixed number of bytes, that is 32 bytes or 64 bytes are commonly used. It representing the different axial positions. For example, the BLU is equal to 0.0001 inch. So this represents the motion up to the 469 inch. Okay, so possible motions. Then next is the direct numerical control. It is known as the DNC. So direct numerical simultaneously control the operations of a group of NC machine tool using a shared computer. Okay. So programming, editing part program and downloading part programs to NC machines are main responsibilities of the computers in an NC system. So Cincinnati, Malacron and General Electric, it first used the idea of direct numerical control in the mid of 16th century. So by 1970, about a half a dozen vendors marketed their DNC systems. But due to the high cost of mainframe computers and introduction of CNC in 1970, the DNC system it couldn't become popularly in industries. Now here you can see direct numerical control. Okay, here this is the host or the mainframe computer, and it is parallelly connected by different MCU, machine control unit. Okay, so the different here you can see this MCU, it controls the milling machine. This MCU it controls the lathe machine. Okay, here it is again milling, here lathe. So the different machine controls are connected with the mainframe computers. So this is known as the direct numerical control. Now, advantages of NC machines. Okay, so let us, it increase the productivity. Okay, it reduce the tool fixture storage cost, it faster setup time, it reduce part inventory, flexibility, the speed changes in design, better accuracy of parts, reduction in part handling, better uniformity of parts, better quality control, and improvement in manufacturing controls. So these are the different advantages of NC machines. So there are some limitations also, and the disadvantages, or we can say the limitations of the NC machines are increase in electrical maintenance, high initial investment, operating cost per hour is higher than the traditional machine tool, and retraining of existing personnel. Okay, so we have to retrain the existing personnel for the NC machine. So these are the different disadvantages, or we can say the limitations of the NC machines. Now, advantages of CNC machine. So first, it reduces the lead time. That means the time between the receipt of drawing by an engineer and manufacturer getting ready to start a production on shop floor. This is called the lead time. So it reduces the lead time. Then elimination of operator error. That is, the program is checked before it goes to the machine. So no error will occur in the job. Operator activity. That means operator doesn't require special skill for machining, and single operator it can operate more than one machine. So we can say operator activity will be increased. Lower labor cost. So one operator can run two or more machines, resulting in the reduced labor cost. Then smaller batches. That means the periodic machining of small batches is found to be economical, and it bring about the rapid stock turnover. So large storage facilities for workpiece is not required. Then longer tool life, that is the tools can be used at optimum speed and feed. So because of this function are controlled by the part programming. Then elimination of jigs and fixtures. So standard locating fixtures are not used on CNC machine, and the cost of special jigs and fixtures is frequently we can eliminate. Then flexibility in change of component design. The modification or changes in component design can be readily accommodated by the reprogramming and altering the concerned instructions. Then reduce inspections. It means normally it is necessary to inspect the first component only, then so it reduces the inspection. Less scrap, since operators errors are eliminated, so the tools are operating under the control optimum condition, so the incidents of breakage should be very small, so the or the rejection will be minimized, or we can say the very less, so it can reduce the scrap. Then accurate costing and scheduling. So in CNC, time taken in machining is predictable and result in greater accuracy, so in estimating and more consistent in costing. So these are the some advantages of CNC machines. Now let us some disadvantages, that is the higher investment cost, higher maintenance cost, costlier CNC personnel, and plant support facility. That means the most of the preparative work for CNC operation is done away from the machine plant support facilities. So will be essential. That is the part programming, tab preparation, and tool presetting. So these are the some limitations of the CNC machine. Now advantages of DNC machine, direct numerical control. So it eliminates the punch tab and tab reader, which are the weakest component in the NC system. Large memory of DNC, it allows it to storage a large amount of part program for subsequent uses, and it also relatives the memories of NC control unit. Same part program can be run on the different machine at the same time without duplicating it at individual machine. Central DNC computer can keep close control over the complete machine shop. Individual machine performance report can be obtained on demand, and DNC uses a control computer which can be easily isolated from the machine shop and kept in suitable environment. And the data related to manufacturing, it can be centrally maintained and updated, so thereby effectively managing the inventory scheduling. Some disadvantages of DNC machines are: in the event of failure of central DNC computer, the complete activities of the machine shop will come to stand still. And the DNC is expensive and its use is justified where the high automation is required. So these are the disadvantages of DNC machine. Now the types of CNC. Okay, so you can see this is the list. There are number of CNC machines are available. Okay, first one is the machining center, in which the horizontal machining center, vertical machining center, and universal machining center. Then CNC turning center, CNC milling, drilling machine, plane milling machine, gear hobbing machine, gear shaping machine, wire cut EDM, tube bending, electron beam welding machine, laser arc plasma cutting machine, coordinate measuring machine, CMM. In grinding machines, there are surface grinder, cylindrical grinder, and centerless grinder, tool and cutter grinder, CNC boring and jig boring machines, press brakes, CNC transfer lines, SPMs, electromechanical milling machines, abrasive water jet cutting machines, flow forming machines, roll forming machines, and turret punch. Okay, so these are the different uh, types of the CNC machines. Okay, so let us stop here, and in our next lecture you will learn about the components of NC-CNC systems, okay, numerical control procedures, then classifications of NC systems. Okay, so thank you very much, friends.